match each equation to the correct graph. To do this, we'll write the equations of the hyperbolas in standard form, then determine the center, and also whether the transverse axis is horizontal or vertical, and then we'll analyze the graph to determine A, where the vertices are always A units from the center. When we have the square of the x part minus the square of the y part equals 1, we have a horizontal transverse axis as pictured in this graph. If we have the square of the y part minus the square of the x part equals 1, we have a vertical transverse axis, and the graph resembles this graph here at the bottom. Let's focus on the two equations where we have the square of the x part minus the square of the y part, which is the first equation, as well as the third equation. Let's first write the equations in standard form. Let's write the first equation as the square of x minus 2 divided by the square of 2 minus the square of y minus 1 divided by the square of 4 equals 1. And let's write the third equation as the square of x minus 2 divided by the square of 4 minus the square of y minus 1 divided by the square of 2 equals 1. Again, notice for both equations we have the square of the x part minus the square of the y part, and therefore we have a horizontal transverse axis, which indicates these two equations must match with graphs A and D. Notice graph A and graph D both have a horizontal transverse axis. The center is always h comma k. For equation 1, notice the center is 2 comma 1. And the same is true for the third equation. But looking at equation 1, notice the denominator of the x part is a squared. We have a squared equals 2 squared for number 1, which indicates a equals 2. But for number 3, a squared equals 4 squared, and therefore a equals 4. Notice the hyperbolas a and d both have a center of 2 comma 1. But looking at graph A, notice the distance from the center to the vertex on the right is 2 units, which indicates a equals 2. And for the hyperbola below, the distance from the center to the vertex on the right is actually 4 units, which indicates a equals 4. This is really all we need to match the equation to the correct graph. Equation number 1 matches with graph A because the vertex on the right is 2 units from the center, indicating a equals 2. Notice the vertex on the left is also 2 units from the center. So number 1 matches with graph A. And equation 3 matches with graph D, again because the distance from the center to either the vertices is a units, or in this case 4 units. And now let's take a look at equations 2 and 4. Notice for equations 2 and 4, the y part is positive and the x part is negative. Let's write the equations in standard form. Let's write equation 2 in the form of, let's write the y part first. The square of y plus 1 divided by the square of 4 minus the square of x plus 2 divided by the square of 2 equals 1. And for equation 4, we would have the square of y plus 1 divided by 2 squared minus the square of x plus 2 divided by the square of 4 equals 1. In both cases, we have the square of the y part minus the square of the x part, which indicates now we have a vertical transverse axis, which we can see the remaining two graphs do have vertical transverse axes. Let's identify the centers. Recall the center is h comma k, where we always determine h from the x part and k from the y part. For equation 2, because we have x plus 2, h is negative 2, and because we have y plus 1, y is negative 1. Similarly, for number 4, because we have x plus 2, h is negative 2, and because we have y plus 1, k is negative 1. So both centers are negative 2 comma negative 1. Going back to the graphs, Notice this is true for both hyperbolas. And now to determine the value of a from both equations. For number 2, because the denominator of the y part is 4 squared, we have a squared equals 4 squared, which indicates a equals 4. And for equation 4, we have the square of the y part divided by 2 squared, which indicates a squared equals 2 squared, and therefore a equals 2. And again, remember, a is the distance from the center to either of the vertices. Looking at graph B, the distance from the center to the vertex on the top is 2 units, which indicates a equals 2. The distance from the center to the vertex on the bottom is also 2 units, which of course indicates a equals 2. And then for graph C, the distance from the center to the top vertex is 4 units, which indicates a equals 4. And of course the distance from the center to the other vertex is also 4 units, indicating a equals 4. Notice equation 2. Notice for equation 2, a is 4, which indicates equation 2 matches with graph C. And for equation 4, a equals 2, which indicates equation 4 matches with graph B. I hope you found this helpful.